Buenos días a todos.
Good morning, everyone. It is a great honor for me to be here in this prestigious Congress. I thank the organizers for the invitation. I'm going to talk about the export flour quality here in Argentina. I'm going to talk about the wheat bread, some milling processes, some controls in the processes, relevant aspects that are important to all destinations. And I'm going to give you two important processes, enriching and eventual difficulties for some destinations that are far from our country, which is the deterioration of the wheat during the transportation. As I said before, wheat bread is the raw material that we work with. In the Argentine Food Code, it is defined as such and is called wheat bread. And this is going to be repeated later on in my future slides. When we talk about wheat, we talk about wheat bread. And here is the same definition of the food code. There is a paragraph that says with very, very good bakery potential. So our industry, something that Diego showed, our bakers make the products that are not exactly bread, but it's called wheat bread anyway. So now comparing this wheat, it's equivalent to a hard red winter wheat from the US. There is some sort of confusion in translation from our part. The ones that provide agricultural machinery, that they call our Argentine wheat as soft, but it's not soft. It's not drum, the one that is used for pasta. It's hard wheat. So it's hard wheat. So when we mill it, it's going to be small. It's going to be semolina and not flour. How do mills classify wheat? Before harvest season and during harvest season, and even before that, there are maps. There is a mapping, there is weather information, INTA reports, and with all this collected information, we can anticipate what's going to happen depending on where the mill is from the end of September, maybe October, up to March. Once the plants start working, colleagues from other countries that import ships with hundreds and thousands of trucks, we do the same thing with trains, 25,000 tons versus 30,000 tons. So if we have the possibility, if wheat is not enough, we can reject it or we can send it to a new destination. That kind of versatility allows the big farmers to have this kind of flexibility. The usual thing is to segregate according to gluten content. As you saw in the previous presentation, the largest flour consumption goes to bakery products. So gluten is a good prediction point for the bakery industry. We select by gluten, and then based on the different qualities, we make the different types of flour. If during harvest season we had a problem, a very specific problem, grains that have been attacked by Fusarium, and we have to separate that. Then in the milling process, we have to use wheat with some sort of problems mixed with a good wheat, and to be able to comply with all regulations. The quality standard that we have to abide by is the one that is number 120. It has 3 degrees with different items, and they are related with the industrial quality of wheat, but not so much with the bakery quality. But some of these items may impact on the bakery quality of the end product. In one of the presentations yesterday, I saw that someone from abroad said that he had a ship with a hectoliters weight of 71. That's very weird to find in Argentina, except for very specific cases. In the wheat standard, grade 3 has a minimum of 73 hectoliters weight. So 71 is outside standards. So it's very weird. In my experience, I've seldom seen those values. We also go from the wheat standard when it comes above 14% humidity, when it has some insects, pests, and it's not complete insects or spiders. Millilotus seeds also. I don't remember having seen any of that, but then there are other more subjective things, such as grains that are covered in dirt. That is really also very hard to find. The bread wheat has also a valuation in terms of its proteic content. Above 11, it's 2%, and below 9, it has discounts. So the one that we now sell is sold to make bread. So the more protein it has, it is more valuable, more expensive. And I heard in a presentation that there are not such thing as good or bad wheat, but there is wheat for very specific purposes. With high level of protein, it's good for bakery products. But if I'm going to make a cookie from bread wheat, I prefer to have one high in proteins. But as you saw in Diego's presentation, the algorithms are very different. The cookies industry is 8% and bread is 10%. So we cannot have all the wheat under low proteic content. We have to focus more on the bread wheat, which is the one that we use the most and we make the most money out of. This wheat grain cycle, I'm going to say very quickly, you know it very well. We can talk about 3 main components: the endosperm, germ, and wheat. And usually it has 81 to 83% of the grain. But with the milling process and the shape of the grain and the way it's being milled, gradual and systematic, by smashing and sanding, it's impossible to extract all the endosperm because it is around 75% in a reasonable industrial performance. When we have the milling process, the small whole wheat particles take the same size that the endosperm, and when we strain it, it's impossible to separate it. This is just a chart that will take a long time to explain. During the making of the product process and during the final product dispatch, we have additional enriching programs: gluten, humidity, falling number, alveogram, ashes, and experimental bakery. And now I'm going to go to exports per se, but in experimental bakery, this is adjusted in terms of the country of destination. For some countries, we have experimental bakery according to the uses and customs in our country. But when we make them for other countries, we make the bread the way they usually make it. We have learned to do that over the years. So, repeating some of the things that you heard before, our main markets are the limiting countries. Brazil and Bolivia are ahead of the game. They're the ones in the top of the ranking. Each one of the countries has its own regulation in terms of the physical, chemical characteristics and the fortification and enriching of the wheat. We respond to both segments, traditional bakery and industrial bakery, in the same proportions, 60-70% for traditional bakery and then the industrial bakery. We export wheat, flours, and premixes, such as bread for hamburgers or whole wheat bread. What happens in the new destinations? That is the challenge that Diego recently mentioned. How do we access and enter those new markets? The general process starts in general with a specification that we get directly from the client or the broker to the different companies, or when it's a large company, they channel it through the milling industry, through their trust fund. But the specification is not enough. The ideal thing is to have technicians, and I've personally done that myself. I've become a technician to go and assess the market. When we can do this, it is sometimes convenient to send small batches, perhaps by plane, and when that arrives to destination, we also send the technician. And we don't make big differences between what the client needs and what we are offering to them. We do this as a test run. And that's because in the new market, wheat is different. According to the presentation from our colleague in Mexico, who said that they used Russian wheat, but they were similar, but we should see about that. How different do they behave in the farm? When the Mexican bakers bakes, how will he see the difference between one type of wheat or the other? So sometimes we have to reinforce our flour improvers, some emulsion, if we have any difference, some enzymatic additives. The Brazilian colleagues know this a lot better than I do, but this is the profile, this is the standard profile of exports for bakery. Mills here produce between traditional bakeries between 0.72, 0.55 of ashes. Of course, 55, the 1.55 is a little lighter in color, and the one in 72 is a little darker. The traditional baker is going to add a commercial additive to make the bread. We are also exporting premixes to make French bread, the one you saw yesterday, with that same kind of profile and focused on traditional bakery. The additives that the baker now adds, they're all already included in the product. They can be used in the direct method or in long fermentations between 14 and 18 hours. This evolved and it changed a long time. It is my experience that Back in the 90s, everything was direct, and right now, in some areas of Brazil, there is a lot more lengthy fermentation with cooling systems. In our neighboring country, in Brazil, the biggest attribute, it has to have a good furnace, a good oven heat. It has to be crunchy. They really appreciate having a thin, crunchy, Frenchish sort of crust. And the cut, when you cut the bread, depending on the region, you value more one attribute than the other, but in general they're very volume, they have a great volume, and they have this crunchy property. This is an example of one type of flour in Central America. Maybe this flour was from the US, but it was not hard red winter, but rather spring wheat. In order to balance with our wheat, we had to work a traditional work like the one we did. We had to send a batch. We have to send a technician to know how we could compensate for that wheat quality. I have very little time, but I'm going to mention this. As I said before, Brazil, Bolivia have different regulations in terms of how to enrich wheat, and Argentina has its own. But that is something that happens all the time in this country. We all add vitamins and minerals to the flour. In Argentina, because of the law 2560, and in Brazil because of their regulations, and in Bolivia because of theirs. If I have time, I'll tell you a little bit about an example of containers that were sent to those countries. So the enrichment of wheat flour is done through a nucleus with folic acid. The practical part of this is there is a technical difficulty, which is parts per million. We have to add 130 or 200 grams in 1 ton of flour, and in order to ensure that flour is going to have those parts per million, it takes time, it's costly, and it's instrumental. So we have to ensure the process. There are certain actions that we have put in place to ensure the process, analysis, verification of vitamins versus the flour that is being produced. Dosifiers are controlled, iron controls, all of that to ensure that the enriching of flour is going to comply with all regulations. And the brief comment about the container, this was an experience that we had a couple of years ago. In a container, we put in a few envelopes on top, above, in the middle, and below. And we controlled, once it arrived to destination, we brought the sensors, and we were able to assess what happened. And as you can see, the upper part of the container had the difficulties of an increase in the temperature. However, in the center of the container and the lower part, it had a much more moderate increase in the temperature. The problem with this is that when these temperature shifts occur, there is condensation, as you can see in the humidity graph, and that sits water on the sack. So, to sum up, we are the link between wheat quality and the flour quality required. And in general, the technology is the appropriate technology. We have a 30-year-old know-how. There are a few difficulties that we have to sort out, such as logistics, so that when we go to farther destinations, we are able to do it. And I think there is a possibility of adding value by exporting premixes, or eventually trying to put our products in shelves in other countries. Thank you very much.